The next chapter that we're going to look at involves conic sections. And last year in college algebra, or Algebra 2, you studied conics from a very basic perspective. The first portion of this unit we're going to look at is conics from the rectangular perspective, which you've done before. And then we're going to look at conics from the parametric and the polar later on in the chapter. So this beginning part is going to be a lot of review of some algebra and relationships of these four different conic sections. First of all, a conic section is created by taking a plane and a right circular cone. And basically what you want to know is the general shape of what the four conics are. The parabola you've seen before is this U shape. You know what a circle is. You know an ellipse is a stretched out circle, either vertically or horizontally. And the hyperbola is this double parabola look. So what we're going to have are these four conic sections. And the bottom of page 141 gives you the formal definition of the conics. We're going to start by looking at the ellipse, which is defined as the set of all points in a plane where the sum of whose distances from two fixed points in the plane is constant. So that's what we're going to be looking at. And the result of all these is we're going to have a shape that looks kind of oval-like, stretched out circle, either stretched out horizontally or it's going to be more stretched out vertically. Once again, the parabola is something that looks U-shaped, circle, you know what a circle is, and then the hyperbola looks like a double parabola, either horizontally or vertically. So before we get into the ellipse, we want to do a quick review of completing the square. Completing the square is used to simplify into a squared binomial. And what this is going to give us is a lot of our conics in a standard form. So first of all, with completing the square, the way you work it out, here's my original problem, is I move all my constants to the right hand side. So I'm left with x squared plus 6x is equal to 7. Then what I do is I take my middle term, middle of these three terms, and I take half of it. Half of it, I mean the constant piece, which is 3, and then you square it. So you take half of that x term, the constant, and then square it. So in this case, we're going to get 9. Half of 6 is 3, 3 squared is 9. With that 9 then, we are going to add it to both sides of the equation. So x squared plus 6x plus 9 is equal to 7 plus 9, which means x squared plus 6x plus 9 is equal to 16. The left-hand side then, I've got something where I've got two factors that are squared. So the factors of 9 that add up to 6 are 3 and 3. So this guy is going to factor down to x plus 3 quantity squared is equal to 16. The other piece is that the half piece that you end up right here is what ends up being inside your parentheses. So we're going to be using that process throughout this chapter. So as we said, an ellipse is formed by the set of points in a plane, the sum of whose distance from a fixed point, which is called the foci, is constant. And we've got two scenarios that we have here. One is going to be a horizontal ellipse and one is going to be a vertical ellipse. So if I were to draw out something that would be the horizontal ellipse, it might be something like this. If I were to have the vertical ellipse, it might be something like this. I missed drawing that down there. It should go through the point. So there's my two ellipses, one that's longer horizontally and one that is longer vertically. The midpoint between the foci is called the center. And we designate the center as an HK value. So in this case, right here would be the center of my ellipse, and right there would be the center of my vertical ellipse. They aren't always at 0, 0. They're at the exact center between two foci. And we're going to identify the foci in a moment. The line segment that goes through the foci with the endpoints on the ellipse is called the major axis. And, let's just put the foci on. The foci are 2 points that are going to be on your major axis. And I don't know if you remember using the thumbtacks with the string, but you would tie a string of a certain length and it would be attached to 2 thumbtacks. And then you'd put your pen inside the string and then sort of pull the string around, and you would end up with your ellipse shape. These 2 fixed points that the thumbtacks were in were called the foci. And then your fixed distance that you had in your ellipse was always the string that was coming from those 2 foci. So the foci are always on the major axis, and the major axis is always the longest portion of the ellipse. So horizontally, it's in the x-axis direction, vertically, it's in the y-axis direction. And the way we can find the length of the major axis, we're going to use the formula 2 times a. The endpoints of the major axis are called the vertices of the ellipse. So right there would be my vertices, and up there and down there would be the vertices on the vertical ellipse. The line segment that goes through the center that is perpendicular to the major axis is called the minor axis. So the minor axis would be this line that goes through the ellipse, or this line. It's the shorter line that cuts through the ellipse, and is found using the formula 2b. The endpoints of the minor axis are called the covertices. And then one last thing that we're going to want to add to this that's not listed right there is the formula for the foci. And the formula for the foci looks a lot like Pythagorean theorem, except for we've got a minus sign in it. So the foci are going to be found using c squared equals a squared minus b squared. The last fact that we have here is called eccentricity. And eccentricity tells us how much ovalness we have in the ellipse. If the eccentricity is close to 0, then the ellipse is more circular. And if your ellipse is in standard form, it is always going to be equal to 1. So it might be some x squared plus a y squared quantity. It's going to be equal to 1. Whereas the circle that you had was x squared plus y squared is equal to, say, 16. And then you know you have a radius of 4. So with your ellipse, you're going to have it in standard form equal to 1.